Hi everybody, this is Andrew. Today we'll be doing the quadratic equation and solving it by completing the square. Recently I did an algebra tutorial about this, so you can go ahead and look at that if you like. So first of all, create a plain text document. Just name it quadratic.html and go ahead and open that in your favorite text editor. This is just Notepad++. I've gone ahead and created the skeleton for us, so you can pause this and copy this if you like. So first of all, we need a doc type tag. Well, we don't need it, but it's ideal to have one to let the browser know that we're using a HTML file. Then you need HTML tags that surround everything. Next, you need the head tags. Now within the head tag, we're going to put meta char set equals UTF-8, UTF-8, that's Unicode. We need the title, that's what gets shown on the tab of the browser, Quadratic Equation Solver. And then we need our script section, that's where we'll be doing all our coding. And finally, we'll need a body. We'll need a body section. That's where we put our actual HTML. Okay, so the quadratic equation takes this form, ax squared plus bx plus c equals 0. Okay, so we need to get the user input. What we need, like we don't know x, this program will solve for x, but we need the user to input a, b, and c. So let's create a function called getInput. GetInput, and we want to validate each thing because we don't want people putting, you know, a equals z or a equals hyphen or something. We want them to only put numbers in. So create a variable called valid, and we'll also need some global variables which are our coefficients, so a, b, and c. And here we'll validate a. Validate a. So we can just use while loops for this. So while not valid, let's do something. So in JavaScript, one way we can get user input is by using the prompt function, which throws up a pop-up. It has two parameters. The first one is the question or the message. So we can say input a. Now there will be some restriction on this because a cannot be anything. So make it clear to the user that it has to be non-zero or cannot equal 0. Cannot equal 0. And we'll also show the user the quadratic equation format, so it's very clear. So ax squared. Now we could use that, but maybe some people don't know what that is, especially if you're not from a programming background. So let's put in the Unicode character for squared, which is so to do Unicode, just do \u. Now the code is 00b2. I looked that up before, I didn't remember that. There's millions of characters, so no, I wouldn't have remembered it, I don't think. So ax \u 00b2, that's ax squared plus bx plus c. Okay, so we're asking them to input a. We'll put a in quotes just so it's quite clear. We can run that. Now to run that, we have to run this function first. So in our body section, we can just write onload equals get input, like that. And that should run after the page is loaded. It should run our function here, get input. Let's try it. So you can just open your HTML file. It should open in your default browser. Okay, and while I'm here, I'll open up, I'll wait till, so input A. I'll just open up a console window, a browser console, so it allows us to check if there's any errors or not. So input a cannot equal 0, so ax squared plus bx. Just say we put a in there, we put a letter in there, which we shouldn't be allowed to do. Yes, okay, it's not going to let us put anything in because we haven't allowed the while loop to break, so we can fix that. So while it's not valid, prompt the user, but we need to say valid equals, sorry, we need to put valid equals true at some point, don't we? So what will valid equal? Well, a, as we stated in the prompt, cannot equal 0, and what else? Well, it has to be a number, so that means it cannot not be a number. So there's an inbuilt function called is not a number, is NaN, so is not a number. We put a in brackets there, but that means a must be a number. So that means a must not be a number. So we want the opposite of that. We want to say a is not a number. Double negative, I know, but so that means a is a number. Okay, let's try that, and that should break now. So input a. We'll try q. No, that doesn't work. Oh, hang on, I'll reload this. I might just load that again. Input a. So I'll try our best case. I'll try the true scenario. So 1. Yeah, that's fine. Reload it. Input a cannot equal 0. We'll try 0. No, it says we must re-put it. Put 2 in there. That's fine. Let's put w. No. Squiggly line. No. 2. Okay. I'll just make sure there's no errors here. Yeah, it seems okay. Great. So that's working well. Oh, what about the case where they don't put a value in for a? Is it letting us? Oh no, it seems to check. It seems to want some sort of input here. Yeah, we'll double check that later. What if we cancel? We'll deal with that later. But at the moment, a cannot be equal to 0 and it must be a number. Great. We'll copy all that. Do the same, we'll do similar for b. Prompt input b. Well, actually b can be equal to 0, so we don't need that constraint. Now what would be ideal here is to already give them the a they've put in here. So to make it user friendly, we should show the a here. So we can do that. We can just do that, can't we? So whatever a value they've put in, we will show it, followed by an x squared plus bx plus c. We'll change that to b, so we're prompting them for b here, input b, and we'll show them the existing a, x squared plus bx plus c. Now b, we shouldn't have this restriction on b, but yes, it must be a number too. Okay. We should reset, before each input, we should reset the valid flag. So we should assume that it's false until proven otherwise, so that this loop will run. Okay, let's try that. Input A, 1. Input B. I'll try putting something strange. No. I'll try to put nothing. Yeah, that's okay. Oh no, it's not okay. Right. It's a bit odd. Anyway, A not equals 0. Yep. We should check that, make sure that the value of A and B aren't null or empty. So we can do that simply by going and A doesn't equal null. We don't want it to be null, so if they hit cancel or whatever else, that I'm not quite sure what JavaScript puts in there if they put nothing. But let's assume it's either null or an empty string. And A does not equal empty string, right? Empty string is just nothing. So I'll go ahead and put that in for B as well. So B cannot be null and it cannot be an empty string. Let's run that again. Okay, so I'll put 1 there, input B. Yeah, I'm pushing enter here and it's not allowing me to continue. And continue and cancel will not work either. So you must put a value. Great, that should be okay. Right, let's do it for C. Validate C, reset the valid flag. C will equal prompt input C. Now we've got A, x squared plus B. We want to use the variable B. So we'll put whatever value of B they put in there, and we'll put there for them. So they'll see their value x squared plus their value x plus C. And then so C cannot be, it must be a number. C cannot be null. And C cannot equal nothing. Although they could put 0 in there, which is fine. You could, in essence, it's nothing. Okie dokie, let's try that. Input A, input B. So we see in brackets here, is putting our values in. 1x squared. Yeah, I know mathematically we don't normally write 1x squared, but we can fix that up. 1x squared plus 3x plus C. Input C, and then they can put their C value in. Good, seems to be working. Now, it's probably x squared is often 1, A is often 1, so why don't we put a default value of 1 in there? We should probably put default values in everything. So what's a real quadratic equation? Well, we could put any values in, of course, but let's put one that's we know the answer to. So B might be 4, and C might be, so two numbers that multiply together to get this value and add to get 4. I'll say 2. So, oh no, sorry, 3. So 1 and 3, 1 times 3 is 3, and 1 plus 3 equals 4. So that'll be a nice even answer. Of course, they can go ahead and change any of these values, but just to save us having to type in 1 every time, because often A equals 1. Give that a quick check. Okay, there's our default value. Input A, we can just hit enter. Input B, 1x squared plus 4x. Okay. As I said before, usually in maths we don't write 1x squared, so we could get around that by wherever we have an A, for example here, we could put a condition. So if A equals 1, we can just use a ternary conditional operator. So that's just following this pattern. You do a condition followed by a question mark. Now what happens if that condition is true? Well, if it's true, we don't want to put anything. We'll just put a nothing. If it's not true, so if A is anything else other than 1, so use a colon, we want to put A. So if it's 3, it'll show A. If it's 1, it'll show nothing. I'll put that down here too. Let's try it. Okay, let's try the A equals 1. See in brackets here, we've just got x squared now. Oh, in C we didn't get it. Wonder why. If A equals 1, show blank. Else show A. That should be alright. Maybe I didn't save it. I'll try it again. One. Yep, that's okay now. So because A is 1, it's only showing x squared. But we'll try it now with a value other than 1, of course we got to test this. Let's try 2. There it is. Input b, so 2x squared plus 4. Great. Okay, next step. So our validation seems to be okay. The next step is we want to show the equation back to the user, don't we? We want to show them what they've inputted and what we're going to do. So to do that, we need to access our HTML. So in the body, let's create a div section. So div, we'll give it an ID. ID equals, you can name it however you wish, but we'll say my div just to make it simple. And we'll just close that immediately. So that from this div we can input HTML. So to get that we can just go, we'll make a global variable. Make a global variable called var my div. There we go. My div will equal, now we need to use the JavaScript command, so document.get element by ID. Now in brackets we need to put that ID, which is exactly what we've written below, my div. Okay? And then with that my div we can start show equation. Let's run a function. Show equation. Oops. Yeah, within our get input method we don't want to start doing other things, do we? So let's just outsource it to another equation. So show equation. We'll first get the my div element and then we'll show the equation. Right. Create a new function called show equation. Okay, now what do we need to do? Okay, well, from our my div we can change its HTML, so use the property inner HTML equals, so this is where we can just put some raw HTML here. So my div inner HTML equals what? How about we say given the equation something, given the equation something, that's where we want to put our something. Equation, let's put the equation string in there. So we'll make a variable here. Actually, let's put a global variable too, because we'll probably need it in other functions. So equation string, there we go, equation string. So given the equation string, solve for x by completing the square. Solve for x by completing the square. Okay, so that'll output that to the screen. We need to do something with this equation string, don't we? We need to create it. So equation string equals what? It's basically what we've got here, doesn't it? This here. So we'll copy that. So it'll be if a equals 1, show nothing. We could apply that condition to b as well, because if you had 1b, we don't need to write 1b, do we? So we'll do the same for b. So if b equals 1, don't show anything, otherwise show b. So bx. Also, if it was 0, which it could be, you wouldn't want to show x, but I'm not going to do that here. You can go ahead. It's okay to write 0x, but yeah, ordinarily in maths you just wouldn't write that term at all. But I'm not going to do that here. It's just extra decoration, really. Plus c. Now c has to be the c that they've inputted. Do we need that bracket? No. Okay, so that's, in essence, that's our equation string. Given the equation, let's put it in bold though. So to put something in bold, you can use the strong tag. Closing the strong tag. Remember, this is HTML, so we should probably put this as a heading or something, or what could we put this as? Let's just put it as a paragraph. Given the equation string, solve for x by completing the square, and close the tag. We should always put our tags in there. Most browsers nowadays are very forgiving, so if you forget things, they often still do it, and it's hard to know that you've missed tags, but we'll give that a go. We'll just go with the default values to begin with. Nothing happened. My div, I'm showing the equation, yep. We're getting the my div, we're putting some HTML into it. A couple of mistakes. I didn't close the strong tag here properly, and the command the property inner HTML should be in caps. So my div.inner caps HTML. Right. So let's try that again. Just use the default values. Here we go. Given the equation x squared plus 4x plus 3, solve for x by completing the square. Okay, we'll just say we can solve for x by completing the square. 2, 5, 1. Given the equation 2x squared plus 5x plus 1, we can solve for x by completing the square. Okay, great. We'll just try, because we added that, we tested whether b is 1 or not, so let's try that. We'll keep that as 1, put that as 1. Okay, so here it's still putting a 1. We can fix that up. But here it isn't. So given the equation x squared plus x plus 3, we can solve for x by completing the square. Great. I'll just go ahead and copy this to each of our b's up here, which is just the 1. Test as we go. 1, 1. Given the equation x squared plus x plus 0. Okay, great. I'm not going to test for 0. Yep, so here x squared plus x plus c. Good. That's looking good. Right, what do we want to do after the equation is shown? Well, we want to show the steps, don't we? We want to show the working. So let's create a function called showWorking. Function showWorking. Let's break this up into manageable steps. So let's do each step one by one. So step 1. What's step 1? Well, if you watch that algebra tutorial, the first step is to get rid of the a term. So divide everything by a in essence. So divide the equation by a if a doesn't equal 1. So if a doesn't equal 1, we want to get rid of it. So 1x squared is okay. So x squared is okay. But if it's 2.5x squared, then we should divide everything by 2.5. Right. So b will equal... should we only do this if it's not equal to 1? Doesn't really matter, I guess. So b will equal b divided by a. C will equal c divided by a. And a will equal 1, won't it? We don't even need a, honestly, because we won't be using it. Right, so how do we do that? What are we going to show? Well, we can go show... Again, we're going to update the output. My div.innerHTML equals... what will we show? Let's do a header first to indicate the... Let's do a h4, for example. And basically want to show the user this. Yes. So step 1, so this is output, remember, so modify it to suit the output. Step 1, divide the equation by A. Now, because it's in a header, we should probably highlight that A a bit. So let's make that an EM. And EM is just effectively in italics. Divide the equation by A if A doesn't equal 1. I'll put that in brackets. Close the header. Let's see what that looks like. Yep. Oh, hang on. I just saw something that we're doing. Can you see that here we say given the equation we can solve for x, we want to keep that on the screen, don't we? By doing this command, by updating this property, so mydiv.innerHTML equals something, it's rewriting all of the HTML. We want to keep what we've already got. So to do that, we put that in there and just add to it. So it means keep everything that's already in the HTML and add this to it. Let's see what that looks like. That looks better. So given the equation x squared plus 4x plus 3, we can solve for x by completing the square. Make that a bit bigger. Step 1, divide the equation by A if A doesn't equal 1. Good. Right, so we divide it by A. We want to output the equation again, don't we? We want to output the steps. So first of all, let's show our string. We'll put it in a paragraph. So we've already created something called the equation string. Equation string, oops, will be our first line, won't it? So because it's a variable, we have to put it as, we can't put it in the text. So the first step is the equation string. Now, if A equals 1, we don't want to show anything else, do we? So let's create a condition. So if A equals 1, we show nothing. Else, what do we show? Well, on a new line, so you can just use the BR, short for break. We can use BR tag to go to the next line. It has to be in text, so in quotes. So if A equals 1, show nothing. Otherwise, go to a new line and let's update the equation. So this is the equation here. Basically, let's put that in there. Now, A is always going to be 1 because we're dividing A by itself, so we don't need to even show that, honestly. We can get rid of that part. But we need the x squared, so we'll have x squared plus b. Yeah, so it'll only show non-1 b's plus c. Right, now that's on a new line, and we have to close the tag, the paragraph that we started here. Give it a go. Unterminated string literal 52. Something I've done wrong. There we go. Just didn't close my string. Okie dokie. Given the equation x squared plus 4x plus 3, we can solve for x by completing the square. Step 1, divide the equation by a if a doesn't equal 1. So x squared plus 4x plus 3. Now, because a was 1, it's only showing that, because there's no need to do anything to that. Let's try it without, where a doesn't equal 1, so 2. There we go. So 2x squared plus 4x plus 3. Divide everything by 2, x squared plus 2x plus 1.5. Great, that's exactly what we want. Step 2. What is step 2? Well, now that we have that, we want to add half of b squared to both sides. This is part of completing the square steps. So add add the square of half of b to both sides. Right? So make a variable called half, let's call it half b, and that will equal, well, b divided by 2. We don't want to modify our original values, let's just keep making new variables if we need them. And we also want a variable called half b squared, which will just equal half b. Simply, we could just go half b times half b. You could use a function, there's probably a power function or something, but this is fine. Half b times half b is half b squared. Now, what do we want to output? Well, just copy what we did above, because we want to keep the same sort of format. Change it to step 2. So step 2, I'll just copy my comment here. Add the square of half of b to both sides. Again, I'll put an EM there. Now, what do we want to show on our first line? Well, let's show our working. So, we don't want this equation string here anymore, do we? We don't need to show a, because a is always going to be 1. We don't need to break at this point, we're already on the first line. So we'll just show x squared plus the b term. Yeah, b term x plus, now this is where we want to put in our new value. So it'll be half b, we'll put that in brackets actually, because to make it clear that we're squaring the b term. So what I mean, we'll output brackets. So x plus half of b in brackets, squared. You remember the Unicode for squared? Plus c. Oops, I better put the output the plus sign as well. I'll just run it because it's hard to see what I'm doing there. Okay, so step 2, add the square of half of b to both sides. X squared plus 4x plus 2 squared plus 3. We haven't got both sides, haven't we? We haven't got the right side. So let's go ahead and put that in. So the equation should be all of that plus equals 0. To be a quadratic that we can solve, we're going to have equals 0 on the right hand side, aren't we? And we'll want to put that in a number of places. So step 1, divide the equation by a. Yeah, the equation string will be there. And here we'll need to put equals 0. Ooh. Good. Step 2. equals 0, because currently it does equal 0. Run it again to check it. I've got two equal zeros here. That's no good. Oops, this 0 here, this equals 0, should be inside this, meaning it only shows if A doesn't equal 1. Let's test. Yep, that looks fine, and we'll just test for the step where A is non-1. That looks fine too. So 2x squared plus 4x plus 3 equals 0. X, divide everything by 2. X squared plus 2x plus 1.5 equals that. Step 2, add the square of half of b to both sides. X squared plus 2x plus 1 squared plus 1.5. Now we have to add 1 to that side, don't we? Whatever we've, because we said here, to both sides. So we'll put that exact thing on the right hand side. Plus half of b, isn't it? Half of b squared here. Oops. Let's run that. There we go. So step 2, add the square of half of b to both sides. So x squared plus 4x plus half of b. Half of b is 2. 2 squared plus 3 equals 2 squared. Because whatever we do to the left-hand side, we must do to the right-hand side in algebra. The next line, and we want to show that again, we'll rewrite that, except that we'll have this computed. Let's put a break in. I'll put that p has to go at the end, so put a break in, and what will we show? We'll show the exact same thing. So x squared plus bx plus, now we don't want the bracket here now, and we don't want the square sign. And we want half b squared, the one that we've calculated here. So we don't want the bracket. We want half b squared, and we don't need the square symbol. Test. There we go. So x squared plus 4x plus 2 squared plus 3 equals 2 squared. So x squared plus 4x plus 4 plus 3 equals 4. Good. Step 3. I'll double check that. Yep, that looks fine. What's our next step in algebra? Step 3 is to convert to the square form. Now the square form, if you don't already know, is just x plus something. Let's call it j. Squared plus something k. Okay, so we want to convert what we currently have into that form. So the first step, again, we need to do some inner HTML work. So step 3, convert to the square form. Convert to the square form. Now in our paragraph we'll have x squared, yep, plus b. Let's go ahead and put all that in brackets just to make it very clear what we're converting. So it's only the x squared plus the something x plus that number that we're converting. the extra number, the original c, it's not part of the process here. So we'll put that in brackets. X squared plus b. Now, here we want half of, we basically want this instead here. X plus half b squared plus that plus c equals half b squared, yep. And we want the bracket after the half b squared. So there. Test. Yes, so convert to the square form. So that part that I've got bracketed is the part that we can convert to the square form. Now, what is the square form? Go ahead and put a break in to make a new line. Well, the square form is going to be an opening bracket, x, not squared, it'll just be x. Yes, it'll just be x plus half of b x plus half of b, closing bracket. Now all this will be squared, these brackets will be squared, so we can put a Unicode squared in there, plus our original c, equals what? Half b squared. Bit tricky with dealing with all these variables in here, I know, because we need the text followed by the variable. But the good thing is you can keep testing until you get it right. C equals half b squared. Close the paragraph. Let's test it. So convert to the square form. So we bracket the part. So this line here is just identical to this, except that we're bracketing what we're planning to convert. So the x squared plus 4x plus 4 part, we change to equal that. So if you know your maths, they're equivalent. So x plus 2 times x plus 2 is x squared plus 4x plus 4, that. Okay, plus the original c equals 4. Good. That is the square form. Let's do the step 4. Step 4 is what? Solve for x. We can solve from that step. So grab my inner HTML. Step 4. Solve for x. To be consistent, let's put x in italics. Now what will we show here? Well, we can just show what we ended up with in our last step. So we'll show the equation that we got from step 3 first. So that's everything before this BR tag. So everything after the BR. Let's run that. Right. So in step 3 we got to this form, x plus 2 all squared plus 3 equals 4. And for the final step, we'll do the same. We'll just show that first. So x plus 2 squared plus 3 equals 4. Now what do we do next, algebraically speaking? Well, we want to get rid of this plus 3, don't we? So we subtract 3 from both sides. Of course, what JavaScript isn't a algebra machine, so we have to program it. So let's go ahead and calculate the right-hand side. Let's create a variable, RHS, so right-hand side, will just equal half b squared, because that's what's currently on the right-hand side, minus c. Right, so it'll be half b squared minus this c. Great. So we'll make a new line here to show our next step. So we'll be repeating all of this. So we'll show x plus half of b all squared plus, now c we don't need on that side anymore, do we? So we'll get rid of that. Will equal it'll equal what? It'll equal our new right hand side. Try that. Okay, except that we're not breaking the line correctly here. The result is fine though. Half, where's that p? Oh, I've got a p here. I've closed the p tag here. That's it. So instead of the closing p, I just put a br in there. So x plus 2 squared plus 3 equals 4. Next line, x plus 2 all squared equals 1. Great. Now the next step, algebraically speaking, is to remove the square. So we just want to find the square root, don't we? So let's create a variable called the square root right hand side. Will equal, I can only think of using a function here, so let's use a function, math square root of right hand side. So the next line, we'll copy all that. The next line will be, so we put a break to make the next line, x plus half b. It won't be in brackets this time because we're removing the square. The square will not be there. And on the right hand side, we're instead showing the square root of the right hand side. Okay. Test that. My line spacing is not working today, is it? The result's fine. Equals, yep. Oh, that p, I keep putting that p in the wrong that, we don't need that p, of course. There we go, that's looking good. Although we don't know that this is working, do we? The square root of 1 is a fairly... If we had something else there, we'd know that that square root's working. So let's put something else there. Back up into our default settings. Let's change it to, say 6 for b. What's two numbers that add to 6? 5 and 1. So we'll change c to be equal to 5. That looks better. So our original equation is x squared plus 6x plus 5. Go through the steps. Solve for x. So x plus 3 all squared plus 5 equals 9. Subtract the 5 to the... Yep, so we get 4. and the square root of 4 is 2. So that looks to be working okay. Now what's the next step? Oh well, I've kind of missed a step here. When we do a square root in maths, you can't just go to the positive. It could be the negative. Can you see that minus 2 times minus 2 equals 4 as well? 2 times 2 equals 4, and minus 2 times minus 2 equals 4. So this should really be a plus or minus. Right? So in our right-hand side, we should be showing a plus or minus symbol. Funnily enough, the plus or minus symbol is just the one before this, so instead of putting the squared symbol, just change that last 2 to a 1. So 0, 0, B1, and I think that's the plus or minus symbol. There we go. So x plus 3 will equal plus or minus 2. Now we have to solve for x. So x could equal minus 2 minus 3, or x could equal plus 2 minus 3. New line. So let's check what the output looks like again. So x plus 3 equals plus or minus 2. So what is this? This is half of b, isn't it? From way back here, this 3 is half of b. So we want the right-hand side minus half of b to get to our answer. So x will equal what will it equal? Half? No, sorry. It'll be the right-hand side, so the square root of the right-hand side, because that's what's currently on the right-hand side. It's the square root, isn't it? So the square root of the right-hand side. Because we're doing maths in output here, we're doing maths in the text, we should put it all in brackets so that the compiler knows that we want to do the maths first. So the square root of the right-hand side minus so it'll be the negative of the square root of the right-hand side. So it's plus or minus, remember? So the negative of the square root of the right-hand side minus half of b. Remembering half of b is that value there. Minus half of b, okay? Or, what else will it equal? Remembering with quadratics, there's going to be 2 answers in general. Or, we'll copy and paste this. It'll equal the square root of the right-hand side, so not the minus, the positive square root of the right-hand side, minus half of b. The algebra is still the same. We always have to subtract this 3 from the right-hand side. If it's negative, that's okay. It'll be just a double negative. That'll work out fine. Subtract, so square root of the right-hand side minus half of b. And I believe that should be our answer. Let's give it a go. So we got x plus 3 equals plus or minus 2. So minus 2 minus 3 equals minus 5. Positive 2 minus 3 equals minus 1. Let's go ahead and just test that in the original equation. So this is our original equation up at the top. So minus 5 squared is 25, plus 6 times minus 5, so minus 30. 25 minus 30 is minus 5, plus 5 equals 0, that's correct. Minus 1 squared is 1. 1 minus 6 is minus 5, plus 5 is 0. Yeah, so that's worked out. So I believe we're done. Let's go ahead and test some other. So let's try 3. So I've got some equations here I did in my tutorial. We'll test some of them inside my completing the square tutorial. Let's try 4. 8 for b, and 3. Okay, so there's the steps. 4x squared plus 8x plus 3 equals 0. First, divide the equation by a. So 4x squared becomes x squared plus 2x plus 0.75. Step 2, add half of b. the square of b. X squared plus 2x plus 1 plus 0.75 equals that. Convert to the square form. Yep. Solve for x. Yep, minus 1.5 and 0.5. Let's try one where c equals 0. So a equals 2, b equals 10, c equals 0. Of course, when you're writing this, you wouldn't write plus 0, but you could, as a challenge, you could try to detect when one of these values equals 0 and not show it. I won't do that here though. So finally we get down to x equals minus 5 or 0, which is correct. Minus 5 squared is 25. Minus 25, yeah. And 0 of course works, so 0 plus 0 plus 0 equals 0. Okay, and that's it. If you have any questions, please leave them for me and I'll try to get back to you. Great, thank you.